If you've ever fallen into a lake or river and then gotten back out and looked down at your legs and noticed they were covered in salt, you might be asking yourself, am I just standing next to an underground salt mine right now? But no, it turns out that's probably just how salty your tears are. The real reason lakes and rivers aren't salty is a little more complicated than you might think. So let's dive in. Even though small bodies of water, like lakes and rivers, can become salty if enough salt is added, they typically don't retain that salt for very long. You see, as surface water evaporates, it leaves behind not only salt, but also heat. In fact, it's this heat that creates giant whirlpools called gyres, which help keep ocean water circulating. All this fresh water dilutes any salt that's already in the lake or river, keeping it from becoming too salty. The ocean doesn't get as much freshwater input, so any salt that enters it is much less likely to get diluted. In comparison, the salinity of the ocean is around 3.5%. So why isn't the ocean as salty as the Dead Sea? In fact, the saltiest place on Earth is a small area of Antarctica called Vanda. They found bacteria living inside the lake's water, as well as small fish called notothenioids. These fish adapted to life in hypersaline environments and use special proteins to lower the salt concentration in their bodies, allowing them to survive. It could save your life. Want to learn more about water? Check out this video. Or if you have your own question, leave it in the comments below and we'll see if we can answer it in a future episode. Located beneath the Antarctic ice sheet, Lake Vanda is a subglacial lake, meaning it's covered by a thick layer of ice. This ice prevents oxygen and other elements from entering the lake, which creates an environment that's incredibly rich in salts and minerals. The salinity of Lake Vanda is somewhere between 40 and 400 times saltier than ocean water. Scientists believe that the high salt content helps keep Lake Vanda liquid despite being under 400 meters or 1,300 feet of ice. Well, that's because the ocean has a much larger volume than the Dead Sea, which means it would take a lot more salts to increase its salinity to match that of the Dead Sea. Also, the Dead Sea doesn't receive nearly as much fresh water as the ocean does. While it does get some from the Jordan River, it doesn't experience much rainfall or snow, which means the salts in the Dead Sea don't get diluted as quickly as they would in the ocean. Hotter temperatures also cause bottom water to rise up and replace surface water, which makes room for more evaporation. This continuous cycle of evaporation and rising temperatures increases the salinity of the ocean over time. You see, lakes and rivers are constantly moving and flowing, which means that any salt that does manage to make its way into them will eventually get carried away. From the composition of the water to the temperature to the surrounding environment, all of these factors play a role in determining how salty a body of water can be. Cold water can actually hold more dissolved substances than warm water. So instead of leaving salt behind when it evaporates, cold fresh water often takes minerals and salts from the surrounding rocks and soil and carries them along with it. The Dead Sea is located in the Middle East between Jordan to the east and Israel, and the West Bank to the west. It's technically a lake, but it has the saltiest water on Earth, which makes it pretty unique. First, it's 400 meters or 1,300 feet below sea level, which could explain why it's so salty. Since the Dead Sea is so low, the surrounding landmass acts as a basin, meaning that any water that makes its way there is very unlikely to leave. The second, it receives water from the Jordan River, which picks up salts and minerals as it flows over rocks and deposits them into the Dead Sea. But since no water naturally leaves the Dead Sea, these salts accumulate over time, making the Dead Sea saltier and saltier. The high salt content makes it almost impossible for life to survive, hence its name. Meanwhile, the ocean doesn't move around as much. Sure, currents flow through it and waves crash into its shores, but it's still largely stationary. Once salt makes its way into the ocean, it tends to stay there for quite some time. First off, we need to talk about how the ocean got so salty in the first place. You see, it all comes down to rocks. Rocks contain lots of different elements. If you look at the ingredients list on the back of your favorite barbecue sauce, you'll notice that most of the time, salt is listed near the beginning of the list. That's because salt is made up of two key ingredients, sodium and chloride. These two elements have a greater affinity for each other than they do for water molecules, which means they stick together rather than dissolving into the water around them. However, when you add just a tiny amount of salt to water, like what you'd find in a lake or river, the sodium and chloride ions quickly dissociate and dissolve. And since they're so tiny, they tend to stay dissolved unless you evaporate the water. And when exposed to air, water, and other natural forces, many of them undergo a process called weathering, which breaks them down into much smaller pieces. Some of these elements, like calcium, sodium, potassium, and magnesium, break down from rocks and make their way into our oceans through rain and rivers. When the ocean water evaporates, those elements are left behind and become part of the ocean's salt. Now, because the ocean has been around for so long, billions of years, it's had plenty of time to collect salts from rocks on land. It also gets a little saltier every year because of the increased acidity of our oceans. See, burning fossil fuels like coal and oil releases carbon dioxide into the atmosphere. That carbon dioxide reacts with water in the air and forms carbonic acid. As a result, our oceans have become more acidic by about 30% since the Industrial Revolution began. This extra acid causes limestone, which is mostly made up of calcium carbonate, to break down faster, releasing even more calcium into the ocean and subsequently making it saltier. Okay, so now that we know how the ocean became salty, let's look at why lakes and rivers aren't salty. However, here's where things get a little tricky. Another thing that keeps the ocean salty is its temperature. On the flip side, lakes and rivers tend to be found in areas that are much colder than the ocean. Finally, another reason that lakes and rivers aren't as salty as the ocean is because they receive fresh water from sources like rain and snow, which, of course, isn't salty. Okay, now that we know why lakes and rivers aren't salty, let's talk about the Dead Sea. The Dead Sea has an average salinity of 34%, which is about 9 times saltier than ocean water. And while the Dead Sea may be the saltiest body of water on Earth, it's not the saltiest place. When scientists drilled a hole into Lake Vanda in 1972 to extract some of its water, they discovered that its salinity was so high, it actually helped preserve a mini ecosystem underneath the Antarctic ice. So as you can see, there are many reasons why lakes and rivers aren't as salty as the ocean. Now, speaking of temperature, the next time you fall into a lake or a river, you might want to check the temperature of the water before you get in.